Good morning. This is Arvind. In the previous session, we have discussed about functions, types of functions, categories of functions, and about parameter passing. In this session, we will revise parameter passing, then see some example programs on parameter passing, storage classes, recursive functions, and passing arrays to the functions. Let us see what is parameter passing. Parameter passing is nothing but it is a technique of communication of data between the called function and the calling function. So it can be achieved either by passing the values or address of the variables. And here the C supports us two types of parameter passing techniques. One is call by value and the other one is call by address. So here the parameters can be divided as formal parameters or actual parameters. So the formal parameters are those parameters which are specified in the function declaration or in the function definition, whereas actual parameters are those specified in the function call. So here, whenever we are using passing parameters, we need to satisfy two conditions. One is the number of parameters in the function call and the function declaration must be same. And the second one is the data types of each of the parameters in the function call should be same as those of the corresponding parameters in the function declaration statement. So here, coming to pass by value or call by value, in this method, calling function sends a copy of actual values to the calling functions. So the changes what is happening in the called function does not reflect the original values of the calling function. Whereas coming to call by address or pass by reference, in this method the calling function sends address of the actual values as parameters to the called function. So calling function performs its tasks and sends the result back to the calling function. Thus the change is called as function reflect. So the original values of the calling function gets modified since we are sending the address. So the calling function needs to pass ampersand operator along with the actual arguments, and the called function need to use asterisk operator along with the formal arguments. So changing data through an address variable is known as indirect access, and asterisk is represented as indirect operator. Now let us see what is call by value. So the default mechanism of parameter passing is called as a call by value. Call by value mechanism does not change the content of the argument variables in the calling function, even if they are changed in the called function, because the content of the actual parameters in the caller is copied to the formal parameters in the called function. So the formal parameters is stored in a local data area of the calling. So there are separate memory locations for the actual parameters and the formal parameters. For that reason, the changes to the parameters within the function will affect only the copy and will have no effect on the actual arguments. So we have separate copies for the actual parameters and the formal parameters. That's why whatever we are the effect that is happening in the parameters of the called function, that is formal parameters, that are not going to reflect the parameters that are present in the calling function, that is actual parameters. Now coming to call by reference or call by address, so this is another technique what we are going to see in C programming. So this is a call by address. Here we are going to pass the values. The address of the variables is passed. So in the caller function we are going to send the address. So in this function the address of the arguments is copied into the memory location instead of the values. So instead of values we are passing the parameters. So in the called function, what we are going to have? We are going to have the pointer variable. Since we are passing the address, where will this address variable store? Address will be stored in the pointer variables. For that reason, whatever the formal parameters we are declaring, these formal parameters are declared with the asterisk symbol. So these asterisk symbols, since we are using a pointer symbol, they are going to have the address of the actual parameters. So whatever the modifications we are making in the formal parameters, those are going to reflect the actual values because we are making the changes in the address place. So because of this thing, the actual parameters gets changed in call by reference and call by address. Now let us see an example program for call by value and call by address. So here let us see call by address. So here the function fun1 is declared, whose return type is void and having two arguments of type int. So in the main, function 1 of a comma b invokes the function fun1 and assigns the content of the actual parameters ab to the formal parameters ab. So the value a value here, this actual value a, what is the actual value a? 10. That 10 is copied into this a. And what is the actual value of b? 15. That 15 is copied into this b. So here this a and b are called as an formal parameters. Here this a and b are called as an actual parameters. So both will reside in different memory locations. Since they are residing in different memory locations, when I invoke the function 1 a of a1 comma b, here I am doing modifications on a and b. A is equal to old value of a plus 10. That is, a value will become 20 and b value will become 35. So what I am doing, I am printing those values here in this function call. But when I again return back to my callee function, so once after calling, it will return back to the control will return back to, sorry. The control will return back here. The control will return back here. So here, these called functions, these actual parameters will not get reflected because they are in separate memory locations. See here, it is a main function. Main is having a is located at the address 2000, b value is located at address 3. So in the stack, what we are having, whenever we call a function, a separate frame of memory will be allocated to the different variables. Whereas when I call function 1, again it will invoke a next frame wherein the a value will have a separate memory. For example, for a is having here the address is 3500 and the b value is having 4000 address. So here the values of a is copied here and the value of b is copied here. When I am doing modifications that are going to reflect the a values here, so a is equal to a plus 10, that is a 10 plus 10, 10 plus 10 is 20. So now this new a value will become 20, whereas b value will become 35. So this is not going to affect the values in the main function. Okay, now let us see here. Whereas in call by reference, so in call by reference, what is happening? The main function invokes the function 1. So here also I have declared it and the main function is going to invoke the function 1 and assigns the address of the actual parameter. So here what I am doing, I am assigning the address of the actual parameter. So A's address is being sent to this variable, this parameter A. So what is this? This is a pointer variable. Since it is a pointer variable, it can hold the address of the actual parameter. And here also it is a pointer variable. Since it is a pointer variable, it will hold the address of B. So in the similar fashion, see here. So here A is having an address of 2000 and B is having an address of 3000. Now what I am doing? I am sending the address of A. What is address of A? 2000. That 2000 I am sending into this variable called function. So A will have 2000. So what is A? A is a pointer variable. So this A will be pointing to this particular address. Okay. Now again, I am sending into this B the address of this variable. What is the address of this variable B? 3000. So that 3000 is copied into B. But what is B? B is a pointer variable which is pointing to this particular address. So whenever I am modifying A value, what will happen? A is equal to A plus 10. So since A is pointing to this address, the value of A is 10. That 10 at address 2000, 10 value will be added to 10 and that is going to change to 20. That's the reason. See, in this case, in call by value, since both are at different memory location, the changes what we are going to make are going to reflect only in the called function. Whereas here, since we have copied the address to these pointer variables, that values are going to get reflected in the main function. So the values in the main function will get changed. So this is what is a call by value and call by address. So here, if you see the program's output, A and B values are supposed to be 10 and 15. So before calling, A and B values are printed as A is equal to 10 and B is equal to 20. Once when I call this function, the control will come here, since function 1 will get invoked. Now after doing the modifications, I have printed the values of A and B in the called function. So A value will become 20 and B value will become 35. The control will come again here. And after calling, I have printed the values of A and B. But you can see that A values are 10 and 15. So the actual values are not getting reflected. Whereas here, so the initial values are 10 and 15. After calling, what happens? See here, I have printed A value and B value. So what is A value? A is having 2000 and B is having 3000. That's the reason it has printed A value as 2000 and B value as 3000. Suppose if I want to print the values at that address, then here I have to write pointer A and pointer B. If I write pointer A, so at 2000 address, what is the A value? 20. At address at 3000, if I have written here pointer B, at 3000 address, the value is 35. So A value and B value will be printed 35. So here, after coming here, in the main function, A values and B values are changed. That's the reason it has printed the values as 20 and 35. Now, let us see another program for call by value and call by reference. For this, I am using the same technique, swapping program. So swapping the values. So initially the A values and A value is 10 and B value is 15. So first I have declared the swap function that is having two int variables. What is the advantage of declaring int? Since I have not given any name, here I have not given any name. So here in the definition section, I can give any name. So here if you see, to show you the difference, here I have used the variables A and B, but here I have used the same variables A and B. Whereas coming to this case, you see I have changed the variables X, Y, because here I have not given any name. If I give the name here, whatever the name I give, here also I need to give. Suppose if I have said int A, int B, then 100 int X, int Y, then 100% here I cannot declare int A and int B. So here 100% it should be an X and it should be a B. So initially when I invoked the function swap, the swap will come here. So it has A value will be 10 and B value 15 is passed here. Then the temp value I am sending it to A value I am storing in temp value, and A is being stored with B value and B is stored with the temp value. So in this case, in this way, if I do swapping, so ultimately the effect is going to be only in the called function, but not in the calling function. Whereas if you see the second example, that is by call by reference or call by address, here I am passing the address of the actual parameters and to the pointer variables of the formal parameters. So X and Y are the nothing but they are formal parameters. So into the pointer variable I am sending the address of A, into Y, I am sending the address of B. So by sending address, what I am doing, I am changing the content. So temp is equal to pointer X. So pointer X is whatever the address at X, the value is there, that will be passed to the temp. So here temp will get the value 10 because pointer A, what is A? A is having 2000 address. So this 2000 address is being pointed here, in that the value that is present is a 10. So temp will have 10 value. Now what I am doing, pointer A is equal to pointer B. So pointer A is here. So A is pointing here. In that what I am doing, whatever the address B has pointed, so B has pointed to 3000. In that what is the value? 15. So that 15 value is copied into the pointer variable of A. Next, what I have done pointer B. So wherever the B is being pointed, in that I am going to send temp value. What is a temp? Temp is having 10. So that 10 is being copied into the B's address pointer variable. So B is pointing to the 3000 address. In 3000 address, I have an B, another B variable. So here I have passed this. Sorry, here it is X and Y. The names are X and Y. So in this fashion, we are going to use call by value and call by address. Now, next let us see what is the storage class. So here in the storage class, storage class is nothing but it is a class of variables which determines whether the item has a global or local lifetime. A variable name identifies any physical location within a computer. So variables in C differ in their behavior, and this behavior depends on the storage class. A variable may assume, for C compiler point of view, a variable identifies some physical location within the computer. Okay, so here what will happen? Whenever we use these storage classes, there are 4 types of storage classes. One is automatic storage class, external storage class, static storage class, and register storage class. So what is a automatic storage class? Where the variables would be it depends on their behavior. So this behavior can be in terms of their storage, where they are going to get stored, what will be the initial value, what is the keyword that what we need to use, and what is the scope and what is the lifetime of these variables. So here the scope of the variable determines over what part of the program the variable is actually available. So in exactly where that particular variable we can use, whereas lifetime refers to the period during which the variable retains its value. So whether it is it belongs to a particular block or it is available till the life of the program, that is what is called as a lifetime. So here we are going to classify based on the behavior. We are classified the storage classes into 4 types. One is automatic storage class, external storage class, static storage class, and register storage class. Here the syntax is storage class, whether it is on auto or external, static or register. Then the data type of the variable. So what is the data type, whether it is an integer or character or float or double, and the name of the variable. So this is the syntax of the storage class. In that, let us see the first storage class, that is automatic storage class. So this is the default storage class for all the variables declared inside the function of a block. Hence the keyword auto is rarely used while writing the programs in C language. So here by default all the variables whatever we are declaring are auto. So there is no need of writing auto. Even if you write or if you don't write, it will consider those variables as an auto type. That's the reason we are not, we most of the times we don't write auto. So auto variables can be only accessed within the block or function they have been declared and not outside them. So wherever, in whichever the block we define them, only in that block we can use. Okay. So of course, these can be accessed within the nested blocks within the same parent block. So same parent block or function in which the auto variables were declared. So they are assigned a garbage value by default whenever they are declared. So whenever we declared a variable as an auto variable, the garbage value will be the initial value. So here, let us see what is the storage. So where it is going to get stored? It is going to get stored in the main memory, and the initial value will be the garbage value. The keyword is auto. The scope is local to the block in which it is defined, and the lifetime is the control remains within the block in which it is defined. So wherever we define it, only in that particular block its lifetime exists. Now let us come to the second storage class, that is external storage class. So variables that are both alive and active throughout the program. So external storage class simply tell us that the variables is defined elsewhere and not within the same block where it is used. So whenever we define a variable with extern, that can be used anywhere. So we can use within that block and we can use outside the block. Basically the value is assigned to it in a different block, and this can be overwritten or changed in different blocks as well. So we, even though we define in one block, we can change the values. So an external variable is nothing but a global variable. So here external variables are something which are similar to your global variables. So initialized with a legal value where it is declared in order to use elsewhere. It can be accessed within any function block in that particular program. And here what will be the initial value? So the initial value of the external variable will be 0. So the initial value of the external variable will be 0. And the keyword what we are going to use for this external storage class is external. And the scope is entire program. And the lifetime of this is till the end of the program. So only after the main block ends, the external block storage will get released. So the main purpose of using external variable is that they can be accessed between two different files which are part of a large program. Now let us see the next class, static storage class. So a variable can be declared as a static variable by using a keyword static. The storage class is used to declare static variables which are popularly used while writing programs in C language. So static variables have a property of preserving their value even after they are out of their scope. Hence, the static variables preserve the value of their last use in their scope. So we can say that they are initialized only once and exist till the termination of the program. The meaning of this static variable is, suppose if we are going to define these static variables in a particular block, we can use only in that particular block. Okay. But the thing is, its lifetime is till the end of the program. Once again, if we are going to refer the same block, then what will happen is it will retain the old value. Whatever is the previous value, that value can be retained. So that is the advantage of using the static storage class. So from this particular static storage class, what we come across is the storage will be in the main memory. The initial value here in the static variable is 0. So the 0 will be assigned initially. And the keyword what we are going to use is static. The scope is local to the block. So we can use only within the block, but the lifetime is throughout the program. Now let us see another storage class, that is a register storage class. So this storage class declares register variables which have the same functionality as that of the auto variable. The only difference is that the compiler tries to store these variables in the registers of the microprocessor if a free register is available. So the advantage of using register storage class is, since they are in the microprocessor, it is very fast to access. So whatever the variables we are going to most frequently, we are going to use, those variables need to be declared to be register type. So since we will be using, if we are going to use them repeatedly, more number of times, more frequently, then always going to the main memory and fetching them from the main memory is time consuming. So to overcome that problem, we are going to store them in the registers. So for that, the keyword what we need to mention is register. So here, whenever we are going to use these register storage classes, they are going to be in the CPU registers, and the initial value will be garbage value. The keyword what we are going to use is registers. And where these register storage classes we are going to use means, we are going to use only within the block. See, they are something which are similar to your auto variables. So their scope is within the block and their lifetime is also within the block. So once when we come out of the block, we cannot use those variables. Automatically the memory will be getting erased. Now let us see the entire thing what we have discussed till now. So we have seen that there are 4 different types of storage classes based on their behavior. So they are auto, extern, static and registers. Auto, extern, static, they are going to store in the main memory, that is your RAM, whereas the register is in your CPU memory, that is in registers. And auto and registers will have an garbage value. So initially when you declare them, they will have the garbage value. Whereas if you are declaring with the extern or static keyword, the initial value will be assigned to be zeros. And the keywords what you are going to use for auto is AUTO, extern is EXTERN, for static STATIC, and for registers you are going to use register. And the auto, the variables what you are going to define as auto, scope is within the block and lifetime ends once we come out of the block. Whereas if you are defining the variable as with an keyword extern, the scope is throughout the program and the lifetime is also till the end of the program. If you are defining it as a static, its scope is within the block. You can use that particular variable only within that block, but it retains its memory till the end of the program. So if you are going to refer the same block again, you will have the old values of that particular variable. That is the advantage of a static class, static variable. If you are going to declare the variable as a register, it can be used within the block and end of the block. The only thing is it is very easy to access because they register in your CPU. The memory lies in the CPU itself instead of main memory. So this is about storage classes. Now let us see what is recursion. So here recursion is a process by which a function calls by itself is called as an recursion. In C language, it is possible for function to call themselves. A function is called recursive if its statements within the body of the function calls the same function. If it is going to call the function in the same function, we call it as an recursive function. A function which calls directly or indirectly again and again is called as an recursive function. So here we are going to call the same function again and again. So recursive functions are very useful while constructing the data structures like stacks, queues, linked lists, trees, so on. So these are mostly we are going to use these kind of recursive functions when we are creating data structures like stacks, queues and linked list. So when a function calls itself, a new set of local variables and parameters are allocated storage on the stack. So we have seen that whenever we call a program, the program will have some stack memory. And whenever we call a function, for each and every function, it will allocate a separate frame. So in that frame, whatever the function, whatever the variables we are using, those variables will have a separate memory. Okay, so here for each and every recursion of the function, you will be having a separate stack, separate function, so separate copy for those variables. Okay, so the main advantage of recursive function is that we can use them to create clear and simpler versions of several programs. So a recursive function is a function that calls itself directly or indirectly, or a function is said to be recursive if the function is defined refers to itself. Every recursive function must satisfy the following two criteria. One is basic criteria and the other one is recursive step. So what is the basic criteria? What do we mean by basic criteria? See here. Here in this particular function, int main, we are invoking the recursive function. What is this recursive function doing? It is it is calling itself. Here we can see that there is no condition. So this particular program, what it will do, it will fall into an infinite loop. So the recursive, this particular program, if you are going to run, it is going to call again and again like that, infinite number of times. So the program is going to never end. Such a thing is known as base condition. So recursion is a process by which a function calls itself repeatedly until some specified condition has to be satisfied. So just like that, we cannot call it. So we need to check some condition. If that condition is satisfied, we need to call it. Else we need to come away out of that particular loop. So in general, how we are going to come away from this is by using if statements. So here I have given one more example here, the same recursive. So recurse is calling itself, main recursive. So the syntax of recursive function is shown here. So recursion is a process by which the function calls itself repeatedly until some condition has been satisfied. So here this is going to fall into an infinite loop. So whenever I invoke a recurse function in my main function, the control will go here, and that in turn is going to call this again is going to call this, like that it is going to call by itself, and it will fall into an infinite loop. To overcome that, what we are doing, we are going to use some condition, that is if else statement, if statement. So the recursion continues until some condition is met to prevent it. So to overcome the base condition, we are going to use some condition. So to prevent infinite recursion, if else statements or some similar approaches can be used, where one branch makes the recursive call and the other doesn't. So when the condition is going to be satisfied, suppose for example I have used a if statement and I have taken my I value to be, suppose that my I value is 10. I value is 10. And in the loop, what I am doing, I am incrementing the I value. And in the if condition, I said when I value is less than 0, come out of the loop. I value will never come to 0 because I am incrementing the I value from 10. So 10, after that 11, 12, 13, so on, like that I value will go on increasing. So here we also need to see that it satisfies the condition. The condition need to be somewhere or the other, the condition will become false. Such a kind of if-else statements we need to use. So here I have given an example program here. So here in this particular program, initially the sum is being declared, and initially the sum is called from the main function. So in the main function, I have called the sum function. Okay. Number is passed as an argument. So I have passed the number as an argument. Suppose the value of n inside the sum is 3. Suppose I have taken this number value as 3. In the main function, I have taken the number value as 3. Since I have invoked the function where it will come to this particular sum. So sum, now the n value will become 3. So and now what it will do, it will check whether 3 is 0 or not. If 3 is 0, it will return. Else what it will do, it will return n plus some of n minus 1. So what is n value? N value is 3. Sum of n minus 1 is 2. So sum of 2. So again it will come here. So now my n value is 2. So since it is 2 is not equal to 0, what it will do? It will return 2 plus sum of n minus 1. So previously my n value is 3. So it will become, here it will become 2 plus sum of n minus 1. So what is sum of n minus 1? Sum of n minus 1 is 2 minus 1. 2 minus 1 is 1. So again it will come here. So here it will be 3 plus 2 plus sum of 1. So 1 is not equal to 0. Again it will come. So it will 1 plus sum of n minus 1. N minus 1 is 1 minus 1 is 0. Since it is not equal to 0, it is equal to 0. Since it is equal to 0, it will return back. So once it returns back, it returns the value of 0. So the value of 0 here. Here it is 1 plus 0. 1 plus 0 is 1. Here that 1 will be written here. So 2 plus 1. 2 plus 1 is 3. That 3 will be written here. So here 3 plus 3. 3 plus 3 is 6. That 6 will be written here. So the final answer, what will come into the result is 6 value. So the sum is printed as 6. So this is how we are going to use the recursive function. Now let us see some of the example programs for recursive functions. So here let us find out the factorial of a number using recursion. For example, I want to find out the factorial of n. So here instead of finding out the factorial of n, taking an input from the console, I have initialized the value of I to be 12. Now I want to find out the factorial of 12. So here in the main function, the program starts at the main, and in the main function I have called factorial of 12. When I call the factorial of 12, what will happen? The control will go here. And here, at the declaration itself, I have given the definition of the function. Okay, so here the return type is unsigned long int. The name of the function is factorial, and it is having unsigned int. So I. So 12 is an unsigned int. So that 12 value will come into this particular I. So 12 is less than or equal to 1? No, false. So it will here written here. So it will become 12 into factorial of 12 minus 1. So here the value is 12 into factorial of 12 minus 1. So factorial of 12 minus 1 is 11. Again it will come. 11 is not less than 1. So here it will return I into factorial. That is, what is I value? 11. 11 into factorial of 11 minus 1. Previously it was 12. So 12 into 11 into, like that, 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into even 1. Equal to 1 also condition is true. 1. Next, after 1 minus 1 is 0. When it is 0, it will return 1. So factorial of 0 value is 1. So like that, it will return the values as 1 into 2, 12 into 11 into 10 into, and the final value of this particular thing will be this value. This value is getting printed. So this is how the factorial of a function we are going to execute. Now let us see another example. So the following example generates the Fibonacci series for a given number using a recursive function. So here we are seeing an example of recursive function, Fibonacci series. So here int main I is I have taken a variable of type integer type I. That I value initially is 0. So now Fibonacci of 0. What is Fibonacci of 0? It will invoke this particular function. So Fibonacci of 0, I value is 0, I is equal to 0. So I is equal to 0 is true. So what it will do? It will return 0. So here at this percentage D, what value will be printed? 0 value will be printed. After that, what it will do? It will increment I value. So now I value will become 1. So Fibonacci of 1. Fibonacci of 1. So here again it will come here. I is not equal to 0. No. So it will come into else loop. I is equal to 1. Condition is true. So what it will do? It will return 1. So now here it will return 1. So percentage D, 1 value is printed. Next, it will increment the value of I plus plus. What is I value now? 2. So Fibonacci of 2, it will go here. So 2 is not equal to 0, 2 is not equal to 1. So it will come here. Here it is Fibonacci of I minus 1, 2 minus 1. Fibonacci of 2 minus 1, again it will come here. What is the 2 minus 1? 1. So it will return here 1 value. Fibonacci of 2 minus 2, 2 minus 2 is 0. Again it will come here. Fibonacci of 0 is 0. So here 1 plus 0, 1 plus 0 is 1. So it will return that value. So again it is printing the value 1. Now I plus plus. What is the I value? I value will become 3. So at 3, 3 is not equal to 0 here. It is not equal to 1. So it will Fibonacci of 3 minus 1. Fibonacci of 3 minus 1 is Fibonacci of 2. Fibonacci of 2 previously we got it as 1. And Fibonacci of 3 minus 2. Fibonacci of 3 minus 2 is again we got 1. So 1 plus 1 is 2. So 1 plus 1 is 2. That value is written and it is printed. Like this, this particular loop is going to get executed 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All the 10 values in the Fibonacci series are going to get printed. So this is what is the program what we are going to write for Fibonacci series. Now let us see passing arrays as functional arguments in C. So in C, if we want to pass a single dimensional array as an argument in a function, you would have to declare a formal parameter in one of the following 3 ways. So there are 3 ways of declaring an formal parameters. So here one is void main function int asterisk palm. So as a pointer I have declared a variable. So pointer array. Next, the second way of declaring an array is by specifying the size. So int palm of 10. So it is an array of size 10 of type integer. So palm of 0, palm of 1, palm of 2, like that, palm of 9. The last one will be the 9. Yeah, or else without mentioning the size also we can declare an array. So these are the 3 ways in which we can define a single dimensional array or multi-dimensional array. If it is a single dimensional array, we are going to have 1 subscript. If it is a multi-dimensional array, here we will have 2 subscripts. If you have 2 subscripts, it is a multi-dimensional array. So, but the ways we can define the arrays in a function is any of these 3 ways. Either we can declare it as an pointer array, or array with the array of some fixed size, or array without mentioning any size. Now let us see an example program for using an array. So now consider the following function which takes an array as an argument along with an other argument based on the passed argument. It returns the average of the number passed through an array of as follows. So instead of explaining the program, so first what I have declared, I have declared a double. So the return size is a double. Get average is the name of the function. It is having 2 arguments. One is of array type and the other one is another variable whose name is size. So these are the names I have mentioned here. One is an ARR. So whenever I am going to define it, I need to use the same names, array of and size. The same names need to be mentioned here. If suppose if I am not going to give these names, I can give any names here at the time of definition. At the time of declaration, if I am going to give any name to the arguments, the same names need to be mentioned in the definition also. That is the key point that what you need to understand. And the order, here you have 2 arguments. So here also you must have 2 arguments. Here first argument is an of type array of integers. Here also the first argument should be an array of integers. Second argument is of type integer. You can have second argument of type integer. Okay. So that is mandatory. Now my function is going to start with the main. The main return value is int. That's the reason I am returning 0. Okay. If I am going to write void main, I can avoid this return of 0. Now int balance of 5. So I have defined a balance array of integer which is having 5 variables. So balance of 0 is 1000, balance of 1 is 2, balance of 2 is 3, balance of 3 is 17, balance of 4 is 15. Now double average, I have defined another variable average. Average is equal to, I am invoking this particular function, get average of balance comma 5. So what is balance? Balance is an array of size 5. So that balance value, so 1000, 2, 3, 17, 15 are going to come into this array. Now my array of 0 is 1000, array of 1 is 2, array of 2 is 3, array of 3 is 17, array of 4 is 50. And what is the size? The size value is 5. Second argument is 5. So size will get 5 value. Now int I, double average, double sum is equal to 0. Initially I have mentioned for I is equal to 0, I less than 5, I plus plus, sum plus equal to array of I. So sum is equal to sum plus array of I. Sum is equal to, what will be the value? Initial value 0. 0 plus array of 0. So 0 plus 1000 is 1000. 1000 plus 2 is 1002, 1005, 1005, 1022, 1022, 1072. Now average is equal to 1072 divided by size. What is size? 5. So 1000, it will return that average. So 1072 divided by 5 is 214.40000. So that value is being written here, and that is being stored in the average value, and that we are printing. So this is how we are going to pass the arrays. And I will explain you how to use an multi-dimensional arrays, that is matrices, matrix addition, multiplication, subtraction, division, these problems in my programming section. So when I explain the programs, I will explain you regarding that. Thank you very much. Thank you for listening to my class.